and I'm interested in what's coming next. And what I think is coming next, and what we all know about, is generative AI, how that's going to transform our lives, and as the Mayor said earlier, this industrial revolution. So to that end, I'd like to invite a representative of Microsoft, Fatos Ismali, who will talk to us about generative AI. We had a conversation last night, and he's a fascinating man. So please, Fatos, please come to the stage. Fatos, welcome. I enjoyed our conversation last night. Now please tell everyone how this works. No.
Here we go. Thank you, Martin, for that lovely introduction. So, hi everyone, my name is Fatos. I work at Microsoft at the moment, so I've been with Microsoft for 5 years. It's actually really great to be here. I was in Kosovo in summer, this summer actually, speaking at DokuTech, in a similar audience like this. Actually, this one feels much bigger, so it's great to see this. As the mayor said, and as the previous speaker said, it's always great to see this thriving community here in Kosovo, and your presence here is a testament of that. So it's always great to see this increasing number of people interested in technology, but also interested in generative AI, which is what the topic of my presentation is going to be. And Martin, we did speak about your interviews that you do, and the first thing you mentioned actually was Kim Kardashian. So I didn't know you interviewed Steve Wozniak. I would have been more interested in that. So it's great to hear that. So my topic is going to be about generative AI. It's going to be a loose introduction to generative AI. So in the summer, in DokuTech, I spoke about kind of like an introductory level to generative AI. This is going to be focused primarily on how do you actually take these models into production, right? That's where the important kind of bit is. So I work at Microsoft with large corporations. They are all experimenting with AI, generative AI specifically, and now they're at the stage where they want to put these models into production, they want to transform businesses, they want to transform internal processes, and make these real. This is about making generative AI real. That's what this talk is all about. So I'm going to level set a little bit for some of you that are completely new to generative AI. Actually, can I give a quick show of hands? How many people have used generative AI in your daily lives? Perfect. And for those of you that haven't raised your hands, you're also using them. Okay, let's dive in. So, I'm going to skip to this part. So what are foundation models? Behind generative AI, obviously we have these things called foundation models. And this is basically what powers these generative AI applications, including ChatGPT and all the other Bing Chat and all the other tools that are now integrating these functionalities inside. So how did we get here, first of all? So traditionally, the way we did machine learning in the past has been to take specific data sets, train models in isolation, build classification models, build detection models, tracking models, action models. All of these are, say, individual models that are trained using different methodologies, different data sets, working in isolation, producing endpoints that you can then use and integrate with your applications. So this has been the traditional kind of way of productionizing machine learning or building machine learning models over the past, 50 years now. With generative AI, things are changing dramatically. So what we have now is we have a consolidation of these capabilities from individual models that carry out specific tasks to models that are now, to basically one model that we call foundation model, which is based on some sort of a transformer model architecture. First established or kind of, let's say, published by Google in 2017. And that can be adapted to multiple tasks. Tasks like question answering, sentiment analysis, information extraction. But behind the scene, all these models, what they are in general, they're token prediction models. It's not as simple as I'm just referring to as a token prediction model, because actually behind the scenes, these, apparently when there's a lot of research in this space, even though this is a token prediction model, it's actually able to learn representations of the real world. So almost create, in quotes, world models. So it's able to understand objects, concepts, temporal representations of things, and so forth. And that's why it's really great in the sense how it works and how it generates answers that are very convincing, very natural sounding, and it's really ChatGPT is basically one of the testament of that. When you interact with it, it's able to understand, what a country is, what a world is, what a planet is. It has these kind of concepts that it creates, and these are learned representations by just training this token prediction foundation model. Okay. And then, of course, we are now coming to an age of copilots. So with Microsoft and other companies as well, we are integrating these generative AI applications inside every tool that you know and use, whether that's Teams, whether that's Outlook, whether that's Excel, PowerPoint, Word doc. All of these tools, productivity tools, are now imbued with generative AI capabilities. And not just these, but pretty much every application that you see out there, at some point in the future, is going to have generative AI capabilities imbued into it. And this is not the end, right? What you can do with these foundation models is quite amazing, right? So you can, for example, take an image like this from Vincent van Gogh and then just extend the vision of the original artist. What could the artist have drawn if he had a bigger canvas? So this is basically all this bit on the left and on the right is generated by AI by extending from the original painting. Now, before I go to the next slide, I'm prepared something that is it's going to probably look controversial, and I'm so glad that the Prime Minister is not here, otherwise it's going to be very, very weird having him see that. I'm hoping that the sound works. If it doesn't work, then it's probably not going to be great. But if the sound works, then you can see also what you can do with generative AI. For example, you can get a job offer from the Prime Minister himself without him even knowing about it. I hope it works. No, it doesn't. Let's see. Yeah, it doesn't work. It's a shame. But basically, what that was going to show is Albin Kurti speaking in his own voice, in his own person, in that generated video, talking about KosICT and presenting and kind of greeting you guys here in this audience. Unfortunately, that didn't work for some reason, technical issues. This is when you do live demos, right? Anyway, the crux of this presentation was going to be anyway about building scalable large language models and integrating them within your applications. So I unfortunately cannot do the Steve Ballmer developers shouting from the top of my lungs. I don't have the stamina to do that. But the focus here is going to be on you as developers, right? So if you're working in a startup company here in Kosovo, or you're just a freelance developer and you want to use these AI capabilities, this is what I'm going to show you now, how you can actually do that. So there are two main patterns when it comes to generative AI that we're seeing in the market. Myself, when I work with large corporations in UK, telcos, financial services, public sector clients that we work with, massive clients, the two patterns are the retrieval augmented generative AI, which is generation, or which is this RAG pattern, which allows you to ground the models to your data. So you probably have seen that these models actually sometimes hallucinate. They hallucinate facts that don't exist, or they say something about a fact that is not true. So intrinsic and extrinsic hallucinations. You can circumvent that by grounding the response of the model on your data. So you take a question from the user, you query your data in the database, which could be a vector engine, and then you add the result of the most relevant document, and then you show the answer to the user. I showed this last time in my presentation at DocuTech, but this is potentially an application where you can use this concept to get Albanian documents from the, let's say, the legislations that are publicly available on Kosovo's agency, for example, that deals with employment law and all these other legislations. You can take these Albanian PDFs, represent them into a vector database with numerical representation that you see there, store them in a vector store, and then any question that you ask in Albanian, we will find the most relevant document and it will answer the question in Albanian based on that document. So that's the pattern that can be used for Albanian documents, but all other kinds of languages as well. Another big, let's say, pattern that we're seeing is conversational AI. So this is the ability for chatbot-like applications to be integrated within your downstream systems, within your data as well, grounded to your data as well. So in this case, in this scenario, for example, you have a chat history, which is the person asking the questions to the bot. You take that through a large language model orchestration layer, which takes the user's question, takes that through a orchestration layer like this in the center, reaches to the OpenAI models or whatever foundation models they're using. Also, it has the ability to integrate with any database out there, any website as well. Could be a database from Progressive Bank, a Telegraphy, for example, news, could be from Giraffe, anything, right? So you can integrate all of these data sets into this architecture and allow users to ask any questions about any of those data sets. So this is in a back and forth conversational style pattern, which we're seeing a lot of companies wanting to create these. Here's one example where I worked with a customer recently. They were trying to create something called a buybot, which is a conversational AI for an AI trying to buy a car from you. So you're selling a car, AI is going to call you, and is going to try to buy the call for you. Is going to negotiate with you. So what happened was, this was a very interesting case. I called it compassionate buybot for a reason. So what happened is, you have a conversation here, the buybot calls you and says, hi, I would like to buy this BMW car from you. Can you please tell me about the condition of the car? And the person says, oh yeah, the car is in great condition and hasn't got any scratches. Then the bot says, great, who are the previous owners? Then there were 2 other owners before me. That's what the person says. Then the bot says, what's the mileage on the car? So it's just asking like historical questions on the car. Person says 140 kilometers, and the buybot decides to give a quote, which is, I can offer you a price for $55,000. How does that sound? Now, this is the thing. What happened with this customer was when they launched this, when the users were able to trick it, and this is where you need to really be careful when you deploy these models into production. Because what the user says was, oh, sorry, but that's too low. I just had my daughter sent to the hospital and we lost our mortgage, so we need more money for her operation. So the model saw that and it's like, felt compassionate about it, about that person, and changed the quote to $62,000. It's like, okay, here's more money then. So this is where you have to be careful when you put these models into production. You have to evaluate them, you have to test them rigorously before you allow the public to interact with these. So how do you do that? Just checking the time. So you first start with the user experience. The user experience is really, really important. And many businesses that I work with, sometimes they get excited about these ChatGPT models. They want to try them immediately. They want to start building applications immediately without doing any, testing or evaluations of how that user experience is going to look like. What is the endeavor that you're striving for? So start always with the user experience. Then once you know what metrics you need to optimize, what the user experience is going to look like, what that user journey is going to look like, then you go into the prompts, the orchestration frameworks and the prompting. So this is where you start thinking about, okay, how are we going to automate the experience for these users using language models? What frameworks are we going to use for orchestrating these language models? What prompts are we going to use? How are we going to orchestrate the prompts as well? How are we going to evaluate these prompts so that they're safe and they're, for example, immune to jailbreak, to hacking, and all these other things that people are doing nowadays with prompting. And then also, how do you integrate with your own data? How do you remove the risk of hallucinations? How do you ground these models to your own data so you can potentially use vector databases for that, where you can ingest and index all kinds of data? So I mentioned some of those in the previous slide. And of course, nowadays you use plugins, so you can integrate your applications, your LLM application, with different types of systems, different types of other applications, and so forth. So this is using the plugins feature. And of course, then you have the foundation models underlying that. So, which models are you going to use? Are you going to use models from OpenAI? Are you going to use models from any of the cloud vendors like Google, AWS, or Microsoft? Are you going to use a Hugging Face model, for example, like an open source one? Or are you going to build your own? Probably the last one, not going to be the case because that takes a lot of money and time and effort. And then you come across this basically Copilot stack, where you have the entire stack defined from the user experience all the way to the underlying architecture and the infrastructure required for that user experience to be real. And very, very importantly, many people miss this, but this is extremely important, and I cannot stress this enough. You have to do evaluation on these models. And there is a lot of industry metrics that we have today that I've listed out here, just a few of them, in terms of how you can evaluate these models for groundness, for relevance, for truthfulness, for coherence, fluency, and so forth. These are hard metrics that you can actually execute against your prompts so that your prompts are safe before you put them into production. So, we talked about the old way of doing machine learning models, which was this ability for us to basically create these models trained on specific data sets that do specific things. This new world, we don't actually train models nowadays, right? In the past year and a half now, I haven't actually trained one single model in my whole experience at Microsoft. It's all about not consuming pre-trained models and fitting them to your data, but it's essentially using these pre-trained models. This is the new world that we're moving into. And this is great. Great for developers who are not, let's say, data scientists or who do not have necessarily the AI expertise, but they still want to use these models. This is great. So with that also comes a whole baggage of development tools, engineering practices, frameworks that you need to be aware of before you can use these models for production. So what happens there? So with this new, let's say, world of consumable OpenAI or AI models, you have three things that you need to be aware of: the state, the flow, and the side effects. So you as a developer have to think about, okay, how am I going to manage the state of these models, right? How am I going to ground these models to specific data? So this is where you think about vector databases. How are you going to manage the memory of the conversation that happens between your model and the user, which could be in-memory database. So that is very important. So that's one, the state. The next bit is the flow. How are you going to orchestrate the functionality of these models to work with your user journeys, right? So every user journey has a different flow and has different dependencies, different intricacies in terms of how you show the results to the user and how you obtain questions from the user. So how do you manage that? And there's a lot of orchestration frameworks out there today that I'll talk about briefly that you can use and leverage for this purpose. And then the side effects, this is a bit of a weird term, but essentially what it means is how do you connect to other systems? How do you integrate with other applications, with other APIs, and bring them into the experience of the LLM, imbue the LLM with more knowledge, with more context? And this is the idea of using connectors and plugins to do that. And when you architect your LLM applications, keep them open. Don't use potentially proprietary frameworks that only a few have access to. Try to be open. And here at Microsoft, for instance, we have this mentality of everything being open. Even our machine learning framework that we use is completely integrated with Hugging Face, for instance, which has now 26,000 LLM models created by hundreds of thousands of people. So you want to be able to integrate these models into your architecture very easily. So always architect future-proof solutions when it comes to this. Okay, so how did we get, I guess, to this? And why are we talking about developers being the center or the function or the center focus of this whole endeavor? Traditionally, with AI applications, it usually was the case where you needed expertise level skills in AI or data science to be able to use AI or data science within your application. Nowadays, what we're saying is that the application developer himself or herself can use these AI models without necessarily knowing AI. So it's all thanks to these AI model developers that we are here. So the AI researchers from Cambridge, the AI researchers from DeepMind, from Google, and loads of AI researchers out there that we are here today thanks to them. So with the introduction of foundation models, now the application developer does not need to know the inner workings of these models. They just need to know how to prompt these systems correctly so you can build meaningful applications. And of course, these app developers want to provide rich experiences for their users. And to do that, you need to be aware of, as I mentioned, the hallucinations that these models have inherently in them, that they don't have real-world access or up-to-date access to real-world content. And you need to be able to adapt for that. So this is where those concepts that I talked about, the state, the side effects come into play. The state being that you ground the models into your own data. The side effects being that you can connect these models with external APIs and then bring that flow. So bring that flow into the whole orchestration layer and ensure that your user journeys are correctly built. And actually this Microsoft has launched where it's doing a lot of work in this space, and they're releasing a lot of open source tools for you to make your life easier. So semantic kernel is one framework, orchestration framework that we offer. LangChain is another one, very public one that is used. Haystack, Hugging Face Transformer agents. All of these are orchestration frameworks that you can use to enrich the experiences and build these user journeys that you're building for your applications and for your users. So it's really important to be aware of these. And of course, the models, as I mentioned, you don't have to use just one model. You can use Azure OpenAI models, you can use Anthropic, you can use Bard, you can use Llama 2, Mistral, which came out recently, which is beating a lot of these open source ones in terms of accuracy, and loads of other large language models. And of course, at Microsoft, we have our own, let's say, tools and offers in this space that make things a little bit easier for you. So if you ever wanted to use some of these that we offer on our cloud, you can always sign up for the free trial and use some of these features that are already baked in. Then it comes that important bit. When you get to that production stage, you need to think about how do you test these prompts before you go into production. And the way you test them, you have to do some sort of bulk testing because you cannot test just one prompt in isolation. You have to test multiple variants of that prompt, including semantic variances in the way you engineer the prompt itself. So bulk testing is very important. Evaluation, as I mentioned, evaluate them against these metrics that we talked about, coherence, truthfulness, groundness, fluency, and so forth, so that your models, so you reduce the risk of those models behaving in weirdly. And then how do you deploy them? How do you actually expose them as APIs to your users so you can actually integrate them within your application stack? And how do you monitor them? If your users are using this in real time and you have live applications using them, how do you ensure that you monitor them for anything that may go haywire? There are tools around this. One of the tools that we have is something called Prompt Flow, which allows you to orchestrate this entire life cycle very, very easily using potentially drag and drop, which you can then just integrate Python code as well into it. But it's all in one place. You can do this yourself as well, but it will take quite a lot of effort and time to do it from scratch. A good example of this, of things going potentially bad from demo to production, right? So I've seen a lot of demos nowadays, people doing all kinds of party tricks with these LLMs, right? So they take, like I was trying to do with Albin Kurti earlier, right? They take a generative AI, generate a video, generate an image, generate an interesting example of using large language models. But when it comes to production, that's when things become a little bit more tricky, and you need to consider a lot of other things, all the things that we talked about. A prime example of this was when Google launched Bard, their own large language model, and they went live. They were demoing it live, and Google was basically, the large language model was asked about the James Webb Telescope, and the Bard language model said that the James Webb Telescope was the first telescope to find the exoplanets, which was not the case. And because of that, there was a lot of media around that, where the model basically went a little bit, basically sprouted incorrectly or factually incorrect statement, And Google, as a result of that, lost over $100 billion in their stock. Just goes to show how you need to be careful about how you bring these models into production, because you can have reputational damage to your company or to your clients as well. And when it comes to production, you need to think about all these different areas, like how do you access private data, so grounding the models to your data, prompt engineering, performance and evaluation, versioning, reproducibility, and AI safety, all the topics that we talked about. And when it comes to managing the life cycle of these models, we now have something called LLM Ops, which is large language model operationalization, which consists of a series of stages where you have, for example, the hypotheses, experimenting, testing stage, where you're trying these prompts in isolation outside of your application stack. And then you're moving into the orchestration layer development, where you're playing around with the different patterns that we talked about, the RAG pattern, the prompt engineering, exception handling, evaluation. You're doing all of that in iteration, in multiple iterations, until you are absolutely sure that these models are behaving the way you expect them to behave. And then you go into the production aspect, where you deploy these models, monitor them, you monitor quota and cost management, you monitor content, you do content filtering on the model's outputs, and you enroll, let's say, AI safety features into this life cycle as well. So this bit is all iterative, right? So you'll go in multiple iterations through this bit until you really perfect, or at least try to perfect, the way the LLM application will work. Another very important thing I want to mention is the handling of latency and limit on the context window of these models. So if you use Azure OpenAI, for example, or OpenAI, these models have an inherent restriction in terms of how many tokens you can send to these models, but they also have a restriction in terms of how much throughput you can send to one API call. One way to kind of alleviate that is by deploying multiple instances in different regions of these models, and then handling some sort of throttling management and load balancing of requests that come from your application to these endpoints. So that's one way to do it. And what I'm seeing with a lot of my customers, they're actually building this logic inside the application, which is a bit of a risk, because the application becomes a single point of failure. It's tightly coupled with the application logic. So you need to kind of, let's say, keep away from that, in my opinion. Lots of people are doing this. For experimentation, you might want to do this just to try and do some sort of load balance testing. But when it comes to production, you probably want to consider something like this, which has a more robust and scalable architecture, where you use application gateways and load balancers that also have geo-replication and ensure that you have, let's say, fail safety on the application management layer as well. This is showing you some Microsoft products, but you can easily replace this with any other products out there from AWS, Google, or any other open source ones as well. But just to show you, because this is a very important, right now I'm facing this challenge a lot with a lot of customers, especially when it comes to deploying LLM applications for voice. So customer calls you, then, for example, that ByteBot that I was talking about, when a customer calls you, there is a latency there that the bot is trying to find the answer and generate the answer. That is like a 1 to 2 second latency. So what happens in that whole experience is that the customer has to wait for 2 seconds before he hears the answer back, which is not the best experience you want to drive. So you want to reduce that latency to milliseconds, and this is one way you can do that. And that's all I had. I think I'm on time.
Fantastic. Thank you, Fatos. That was definitely the most complicated set of slides that I've ever seen. Jesus Christ. Thank you so much. So now we know everything about the depth of generative AI. I just would make it a little bit more simple. Is it going to take everyone's jobs, or is it going to be humans in the loop, or what's going to happen?
Look, I'm going to be brutally honest. Like, there's going to be a lot of automation as a result of this. We live in a capitalistic world, and part of the foundation of capitalism is to drive efficiency, ever-increasing efficiency and effectiveness. So if you're a company in the market today leveraging generative AI, and you're making your processes more efficient than your competitor, the other competitor is going to be, tempted to do the same. And that's going to push the innovation even more. It's going to push automation even more. And the real question is, are we ready to be on the same pace in terms of replacing the jobs that are going to be lost with new jobs. So that's the
One of
real
the
problem.
things that I think about new technologies is that we're always offered the hype, and then it takes longer to come to fruition. In this case, it seems to be coming faster than we think it's working.
Definitely
Would you agree
faster.
with that?
Definitely much faster. It's just the pace of development and innovation. As I mentioned last time in DokuTech, I presented a slide which showed these open source models. There were about 20 or 50 of them, let's say. Nowadays, in Hugging Face, we have 26,000 models that are being developed. So which is a great, great innovation. It's great innovation, but there's a lot of risk as well.
Absolutely. Well, listen, thank you for a fascinating presentation.
Thank
One
you,
more
everyone.
time, please.